What about you? Now here we have an old Mercedes. There's 210,000 miles on it. Stick the ignition on. Big red light. Visit workshop. That's the auxiliary battery. I have actually the auxiliary battery out of it at the minute. But give it a wee start. And you scroll through the screen. We'll have that warning as well, coolant level, and it needs a service. So in this one here, we're interested in that. So the obvious thing to do is check the coolant level. That seems okay to me. Definitely coolant in it. And but I already did that. So there's a wee sensor in below there. You can just about see it. And we're going to have a wee look at this sensor. So there's one wee screw at the back here, and it's just a wee plastic screw. You can ring that very easily, and it probably won't screw out on you. So you need to sort of tease it up. It's just really a popper screw. So we'll give that a go. So you need to get underneath the head of it here and pull it up at the same time, and that's us out. So that's that wee boy there. So it's just a wee popper, but there is a star head on it. And the coolant bottle will just lift out. It's just in wee rubber grommets. And we'll get just enough to get this sensor disconnected here. And the thing about these sensors is they're actually, the sensor itself doesn't touch the coolant. It's in like a tube, so you don't have to drain this, and you just turn it anti-clockwise and give it a pull. So there's our sensor out, and we'll just bring the wiring around here to the front of the car, and we'll set that down roughly into position again. So there's our sensor, and there's our plug. So we'll have a wee check of this sensor and see what way it operates. So this wee video here it's more about the thought process. This is you might think this is a silly wee fault here, but it's more about the thought process and how systems operate, circuit design, and that's what we're looking at. So here we have our wee sensor out, and there's very fine wee pins in it there. So we're going to use the smallest size of these breakout leads to pin out that, and we'll get connected on, get a good connection on it. So that's our sensor pinned out. That's reading 109 ohms, as you can see. So we're going to use a magnet. This sensor doesn't work on resistance or capacitance. Doesn't work like the Volkswagen ones. All this is a switch. So in this state, it's 109 ohms. When you offer a magnet up to it, it closes the switch, and it's just an ohm. So that's basically it. So inside the coolant bottle, there's a float with a magnet on it, and when it sits up, it'll read 109 ohms, but when the float comes down, it closes the switch. So this is the sensor out of the car, and it is actually working correctly. And we can actually verify that because I actually have a new sensor. The car came with a new sensor. Okay, so here we go, genuine Mercedes part. That's the part number there. It's described as a switch. So it's A220055054. This is it. Now it's slightly redesigned, as you can see, from the old one. It's actually a wee bit bigger, a wee bit longer, and the top of that you can see out or not is is open there. Put a bit of light on it. So we can see that one there is open, yet that one there is closed off. So this sensor, I believe, was about £15 from Mercedes. You can get other ones. Fabi make it. It's a wee bit cheaper. You can maybe get it for a tenner. So we're going to change this out anyway, and I'm going to verify that this sensor performs exactly the same as the one that came out of the car. Okay, so that's our new sensor, or switch it really is. In it, it's just a switch. It doesn't really do much else than that. So what we'll have in that, there's a 109 ohm resistor in it, and there is a switch that's acted on by magnetism. So that one there is going to 0 ohms. So it may be that that one there will reuse this one, because it's going to the dead 0 ohms. Well, I think there was 1 ohm on that one. So yeah, probably is a wee bit cruddy in there because it is open, and this one is not. So it has been modified. So we will change this anyway, but it doesn't look as if that is our problem. So a wee unusual feature of this circuit design is that the coolant level indicator switch and the washer fluid indicator switch are actually part of the same circuit. So you could have actually a fault in either one, and it may give different faults on the dashboard. So as we can see here, S41 is the coolant level switch there, and S42 is the washer fluid, and they're connected together in series. So we have two resistors, and we know that this resistor here is 109 ohms. So we have then two switches which we're able to close with the magnet. And if we go down, this is an analog to digital converter, and it gets, whenever these switches are closed, then current flows through these two resistors. So it's able to differentiate between the two resistances depending on which switch is open or closed, or both. So the normal, what we're trying to find out is the normal state. So the switch status here, messages, which is described here. So down here it says when the coolant level indicator switch S41 is closed and the windshield washer fluid level indicator S42 is open, the message check coolant level appears on the screen. So the normal state of affairs is that those switches need to be open. So if I put the magnet on this switch, that jumps the resistor, so that's a dead short, there's no resistance. And same on this one, so it needs to have those two switches open. There's my hand on the road there. Those two switches open for no warning messages to appear. So there's a bit of information here. It's basically a voltage divider circuit, and that's so the SAM control unit and the fuse relay module detects whether current flows through the resistor R1 or the resistor R2. So that's what it's doing. It's so pretty simple circuit, but it's made a wee bit complicated by they're using the same circuit to use for the two sensors, as it were. So to prove our wiring integrity and all that, we will test this, but we'll do it outside the bottle. So we'll just plug that brand new sensor back in again. It seems to work a wee bit better than the one that was in it, so we'll just use that. And we're just going to stick it in this wee hole here, just to hold it in place for us. And to get the message up, we actually need to start the engine. So we'll go to the car. That's the car running, and we'll have just the one message on the screen, and it's the one for the auxiliary battery. So what it could actually do is, if we put our wee magnet on that, we'll see if we can get the fault to reappear. So I'm going to put our wee magnet up against this, and that'll close that. And there we go, fault's reappeared. So if we take the magnet off, that message disappears. So when it's in that state there, there's no fault. So with this out of the car, so we'll have a couple of options here. What we could do is just stuff that sensor down in there and just let it rattle about, put a bit of tape around it. But what I'm going to do, what I think I'm going to go for is, it must be the float with the magnet in it in this bottle is stuck down. Now what it could be is the float is either stuck and it's not rising up and down with the coolant level, or it's perforated and water's got into it and it's sunk basically. So if that's the case, we need new reservoir, and I don't know whether the guy will go for that in this car or not, because I'll just tell him that that facility is now gone. What you could do also is you could put 109 ohm resistor and across that and just completely bypass it. So what I'm going to do is I'm going to try and see if I can fix this. So the car's in for service, so it's going to go up in the air, and we'll get that the wee auxiliary battery is on charge. So that's where the auxiliary battery resides in there. So I'm just going to show you that a wee second. So this is our auxiliary battery out of the car, and we can see it's a wee 170 amp 12 ampere hour, pretty small wee battery. And I have it actually on charge. Now, I don't know whether this will bring this back again, but I have it on charge in that wee C-Tech, and I have it on the wee indicator for a motorcycle. So that one there, the wee motorcycle one, is for small batteries up to 14 ampere hours. And what it's doing at the minute, it's in that pulse mode. So this may not bring this back, this may not work, it'll probably need new battery. But I'm just putting this on just to see if we can bring this battery back. So there's it pulsing. Voltage is jumping up and down. Now whenever I took this battery out, there's a pulsing again. Whenever I took this battery out, it was measuring 10.5 volts. So that's why the red warning message came up on the screen. So it's quite easy to detect that. Didn't even put a scan tool on it or anything like that. So 10.5 volts out of that battery. Normally these batteries would be about 13 volts or something like that. So if I take the charger lead off, that's the voltmeter has just jumped off. Put that back on again. There. It has brought it up by a volt. It is starting to drop a wee bit. So that was originally 10.5 volts, and now it's just shy of 11.3. So it is maybe going to bring this back. I don't know. So we'll keep this going for a while, and if we connect that again, our wee C-Tech charger over there sitting on my scrap pad, and it goes back to pulsing it. So it'll be interesting to see if that actually works. Right, so we're under the car. We've have the under trays off, and that is the coolant plug. So we have a basin underneath, a few drips and then stop. So this'll let us open this coolant up, and there she goes. We'll just drain enough out just to empty the reservoir. Okay, so that's the reservoir out of the car there, and as you can see, that's where our switch goes into. So we can get a better view of it now. And it's just a hole there. So that's the one that came out of the car. It just slides in and turns. Dead easy. That's the outlet, and that's the return. So not much to it. So because we have the two, I have that new one, the new version, hooked up, the Vantage. So 109 when it's normally hooked up. So try and get that in the shot for you. So that's our thing in. So what I did was I run this under the tap and I give it a bit of a shake about. There's a float here and you can hear it clattering up and down. So whenever we put it that way, that's us to know it. So the 109 is with float up. So it floats up a bit there, and whenever the coolant, this is simulating the coolant being down. So what the next thing we need to do is we block this hole and fill it full of water and see if this float is actually floating. Now unfortunately I can't actually see it. I can't really see it. We can hear it. So you can hear that popping up and down there. So it just sounds like as if there's a stone in it. So what I'm suspecting that this float isn't floating. Right, to test this theory of this float not floating, we still have the sensor connected. It's reading 0 ohms. If this bottom bit plugged with a bit of, you can't see it, it's out of shot. It's plugged with a bit of fuel line with a bolt on it, but it's still dripping a wee bit. So we're just gonna, I've got our supporting fairly level, and just gonna pour some water out. At the same time, keep an eye on the resistance. It's dripping a wee bit out the bottom, but so when that float rises right up to the top, it should go to 109 ohms, and as you can see, there's no change at all. So we'll just check. We'll just check the level. Yeah, it's right up. So that float must be perforated, and it's not moving. So the float isn't floating. So there's no fix there. This is a completely sealed unit, so it's a new coolant reservoir. I doubt well the guy will go for that. You know, it's not leaking, so what we'll do is we'll just keep the sensor off and keep it to the side and tell him that that facility is not available now. So we'll see how we go from here. Right, okay, that's our coolant reservoir back in again, pipes connected again, and I spoke to the customer, the owner of the car, and that's what he's elected to do. We've tied the sensor externally, and that just gets the alarm off the dash. So he's well aware that that facility is no longer there, but it won't have any effect on the running of the car. His thinking was that, well, most cars don't have that, so you don't really need it. And just moving over to his wee auxiliary battery. It's been on the go there overnight, and there's the result of it there. It has locked out. So the red light on there, and it hasn't got past the pulse stage. So that battery is scrap, and in order to get that warning light off, it's back down to 10.6. So that's going in the bin, and I recommend the new auxiliary battery for him, and that'll be his warning lights off. So all I have to do now is just complete the service in this car. There's a V6 engine, so a couple of air filters, fuel filter there. Takes about 8.5 litres of oil, this thing. This is a 3 litre V6 engine. So we'll reset the service indicator for him, give it back, and see what he wants to do with the battery. So I think that's it for this one, and many thanks for watching as ever, and all the best, and bye bye.